Hello, hello. Are we here? Are we doing it? Are we streaming? Are we talking? Are we chatting? Ah, it's just a way of baiting engagement. It was on the whole time. I was just doing this. Yes, blue shirt. I needed a lighter, not necessarily in color or hue, but lighter in material shirt for the heat. I know. Keep you guessing. I do have a pink linen shirt, but it was awfully creased, and you guys deserve better than that. Right. So Jolt, I think. I think that's what we're doing. I have some thoughts. Let's have a look at U-Game. What were we doing? What were we looking at last time? Matthias, hello. Sam, hello. Oscar, hello. Julian, can't remember if I said hello, but if not, hello. If I did say hello, then I rescind the second hello so you don't get more than everyone else. Was I looking at physics? I was looking at what we were doing last time. And someone said something interesting, which I've been thinking about a lot. So we have, this is from the previous project. We had a way of creating a shape, and then we had a way of creating a rigid body. But you must first construct this shape and pass it into here. And, oh, sorry. Right, start again. Hang on. I always recommend learncpp.com if you want to learn. It's kind of, I mean, I've not worked through it all bit by bit myself, but I've had good feedback from people who have recommended this to before. Nope, didn't even look to see what was wrong with Nightbot, so I guess we'll just have to deal with it. Because I completely forgot. Right, so in the previous project, we forced the user to create a shape, right? This is some perfect forwarding nonsense, bit of C++ magic, really not that interesting. And then you could create an rigid body, right, with the shape, the position, and the type. The more I think about it, the more I don't like this API, because there is no need to ever construct a shape to not pass it into the rigid body, or at least within like the way I foresee using it. I can't see why you would want to create a shape. Maybe if you wanted like a collider, but I still think you would want that as a rigid body potentially. Anyway, so I think to start off with, because I still don't know what I'm going to be doing all the way through, these two should be combined. Share shapes between multiple rigid bodies. Were we doing that, or were we just constructing one per rigid body? Like, is there an optimization for that? I really can't remember, but I feel like the API should just be simple. It should be just like create rigid body, like should be like create cube, create cylinder, create mesh rigid body, right? And then just combine those two into one. Like why make the user jump through the hoops of doing that? Maybe I'm wrong. Maybe we do want this, but I want to start off with this. And then someone quite correctly pointed out that a lot of this like box shape nonsense, like this does a no, it's a shape, sorry. So we got all this shape and all these rigid body stuff. So somewhere in rigid body, we do a bunch of like Jolt physics system specific stuff, and I feel like this should be hoisted out into the physics system, and the rigid body itself should just be a container for some internal handle back to the physics system, which I think you probably get through the body interface. So a lot of this I think can be cleaned up a little bit. And then, what else was I thinking about? I think as well we need to, from the start, use the sparse set, because we did a lot of design before doing the sparse set, and I've not had the chance to kind of retrofit that, so we should be using that going forward. So I think the physics system should just be like, can I have like a box rigid body with these dimensions? And it'd be like, sure you can. Here's a handle to it. I think that's what I'm going to start off with. Right? If we need to change it later, we need to change it later, and I'm happy to go back and refactor it. But I want to keep it off. I don't want to necessarily just jump straight into the previous design, because that not necessarily this design was not necessarily right. So I think we want like create box rigid body, create And that way I don't need, at least to start with, to create all these. I mean, look at all these abstractions I've got. I've got like a box shape and a cylinder shape and a blah shape and a whatever. Like, just have Jolt figure all that out, right? There's no need to persist that, because we just get like a type, a rotation, and a position, and then we have the ability to set linear. The set linear velocity is interesting as well, because if it's static, should we expose this? Probably not. If it's because we're going to have two types of rigid bodies, right? We're going to have static ones, which are basically the level geometry or proxy for the level geometry, and they are never going to move. So why, and they cannot move, right? So why have the ability to give them set the velocity, right? So on the one hand, like this means nothing if you pass in rigid body type static, which I think is this enum here, right? Yeah. So, but then you've got an interesting design choice, because I'm presumably going to want this. So I'm going to start out not building this, right? But I want to keep this in mind as we go through that. At some point, presumably we want to be able to set, I think we had this so we can like fire bricks, which we never ended up using. So maybe we don't need this at all, but it's just something to bear in mind that we could then maybe make this hide this behind a concept, or sorry, apply some sort of concept to this. So this function you can't even call on something, which means you then have to have the rigid body templated on whether it's static or not, which we might want, don't know. The other one is we have two types. We have a static rigid body and dynamic rigid body type. Either way, like, you're going to need separate types, right? And whether we codify those as actual types or just use templates, I haven't really decided yet. But also, like, we're probably going to want to be able to change we're going to want to force the position for these, right? Because like in the level editor, when I draw a box saying I want a rigid body here, like it's highly unlikely I'm going to get the position of that box right first time. So I'm going to want to move it around. So there's going to have to be some sort of escape hatch for that as well. So I'm like, there's many a question, but I think the only way to answer those questions is just to like start writing some code. So let's have a think about this. So what have we got so far? So we've got, let's look at our physics. Well, let's just not even running doc. I had to reboot my machine to get some updates, which means I lost all my tabs. I lost all my anonymous tabs. Nothing started. Like, this whole thing's a bit of a joke. So just wing it, mate. Yep, we'll just throw caution to the wind. Let's just check this still runs. Lucas, hello. We're hype training. We're doing it. I think I'm right. Okay. So this is fine. This is still doing. So what I want to be able to do is I want to spawn, and I want to see a box, or at least a wireframe of a box, like fall down. You and me both, mate. You and me both. Alas, it seems to be working for now. A bit blurry, some of the SSAO, but I think we can fix that later. What's that? Stack trace, but that's the profiler. Whew. Okay, so we got this as our physics system. So we're going to want. So let's do e source physics. Let's just create a rigid body. Let's just create a rigid body. Let's just. I like to start off with interfaces because that's the tricky part. Everything else is just typing on a keyboard. Oops. Ooh, I am particularly shy at typing today. Okay, so let's do class rigid body. This is going to have some stuff in it. Not sure what yet, but we're going to want one of these, right? Cannot see the bar at the bottom where you type. Oh. That better? Again, I lost all the windows and everything, so I had to remove them around. So I don't even know if the font size is right. Let me know if the font size is too big or too small. Right, okay, so I'm going to want sort of something to encapsulate the rigid body. And then where did we do the... Is it scene where we use the point... So, point light handle. Okay, so we have to have this using. That's fine. Okay, so let's go back to physics system, and then we're going to have include collect content core sparse set, and then we're going to have using rigid body handle equals sparse set rigid body, which I've not brought in yet. Is it handle type? Rigid body, something like that. So this is what we're going to return. So we're going to need some sort of auto create box. Do we even need to specify rigid body? Like, if we don't support soft bodies, create box, is that? So, like, I feel like this second one here is redundant. Like, you can infer that from the return value and from the context you're calling it, right? So, great question. Rigid body is separate from the collision shapes, right? So in my abstraction, I want to kind of unify those because I don't think they make sense, at least what we want to do to keep them separate. So the rigid body will be the thing that exists within the physics simulation, which includes a mass and a velocity and angular linear momentum, as well as the physical space that it occupies. So I think we can just like create box, right? Like just give me a box, mate. Just my box, and then we can have create whatever sphere, tube, cylinder. That's the one. Mesh. How's it going? Too soon to tell. Too soon to tell. So far, I hate everything. So let's do rigid bodies. Pool table shape. I mean, sure. If you want to make that a specific first-class feature of the game, then sure. Betty, hello. And then what's the way? How do I reify this? How do I reify this? I want something like const expra rigid body auto this self rigid body handle gives you a stood optional. No, we can just leave that to be deduced, right? Is it this auto? Can you show the compiler setup settings? The source code is available for this, and so it's just those. I'm just right in the middle of this. I don't want to ruin my flow, but it's just pre-standard CMake and C++26 settings. Can I hoist that down here with the deduced return type? I can't remember if I can. Looks like Nightbot is once again working on YouTube. So we want to do return self.rigidbodies. No, isn't it handle? I think that's all we need. So again, you can, and I'm going to keep this rather than overloading the square bracket operator for physics system. I don't think that makes particular sense. Like if I index into a physics system, what is that going to give me? Like you might be able to assume it's the rigid bodies, but I think that might be taking the abstraction a bit too far. So I think we can basically get me the rigid body here, and you'll obviously get back an optional ref of whether that exists or not, a reference to the real thing. Okay, so I guess we just need to implement this then, right? So that's easy enough. We can go here, and then we can go down here, and then we go here, and then we're going to slap this in here, and then we're going to go FC physics system, and then how do I? So I want. Does using brackets return new entry if it doesn't exist? Or does your sparse set just return something? It returns a optional ref, which is a new C++26 feature, but we can go sparse. I can show you this. Here, I actually have to deduce it to make sure the constant is correct. But you get here a optional ref type of the type, and that will either be a const ref or non-const ref, depending on whether you called it on a const or non-const instance of the object. But no, it's a good question. It's worth clarifying. I think this can be shifted down as well. I don't think there's any need for that to be there. I could probably type this. A lot of this code needs a little bit tidy up. Okay, I'm going to just look at what I did last time and hope I can remember what it is. So I can do. I have like a const auto body settings equals JPH body creation settings. And then this takes, can I see what it takes? So this takes a shape, a position, an orientation. Oh my goodness, it takes bloody loads. An in motion, sorry, not in motion. It means it's an invariable because I've got this weird like half Hungarian syntax. A motion type, and then the object layer that it applies to, which I think we will convert our types to. So we're going to stick all of our static ones on one layer and all of our dynamic ones on another layer. So in fact, this. So we're starting to think a little bit about what we're going to need. Right, so do you think we can use an AABB for this? Or do we want just... Because we've got this, right? Is that intuitive to use that? Or would we want a position and then extents? So that's basically what this is. But how easy is this to construct? Do you see the point I'm trying to make? Like, this feels mathematically more correct, but I feel it's not that ergonomic to say, because I'm going to know the position. I'm going to know where the center of box is. Like intuitively, when I'm describing the system of what I want, it'd be like here's where it should be in world space. So then to construct a min and max around that. Well, you have to remember, like, broad phase and narrow phase is actually kind of irrelevant to me in the sense that I'm handing that over to Jolt to do. This is just my API. This is just how I want to communicate to the world, right? This is the bit I kind of deeply care about. Is like for the user of this physics system, which is only me, to be fair, but from future me, what do I want to be doing? I could do both, but then I'd have to have two overloads, and then I feel like then like it gets a little bit gnarly at that point. I'm going to go AABB, and I'm going to live to regret it. So AABB, and then this is going to need a... Where do we define the types? I've already forgotten my static physics layers. Okay, fine. So we might as well just tell it the layer it wants to go on, rather than creating another enum to say whether this is static or not. Like let's just, which I think I did in the last one. Let's just be like stick it on this like physics layer. No, I'm not going to be doing anything with the ABB. It's just more just like I said, ergonomics. When I come to call this to create the box, like what do I want to be passing to it? I could write some util functions to convert like a point and a center and an extents, got there in the end, into an AABB. That's a mouthful, and I really regret starting that sentence. Okay, so we're getting this. So this is going to have some horror in it, which we're not quite done yet. Ooh, hello. What do you mean out of line? Ooh, steady. Again, I don't care about collision detection. That I'm handing that off to Jolt. I'm just like, I just have to construct a shape. I just have to. It's all going to have to get munged into Jolt types anyway. So again, it's more just like the vocabulary types that I want to use in my interface, right? How do I want to communicate with the outer world that you should be creating a box? How that actually becomes a broad phase, narrow phase collision is absolutely irrelevant. No soft bodies. Twitch chat is dead on the overlay. Oh no. I can see it. No worries. People on Twitch are thinking more deeply. YouTube people are just talking more readily. Okay, so we got that, and then I need to do. I need to create this. What's this body type? What is this body type? Rigid body. Rigid body. So I need to create some sort of auto body equals. I'm just mapping out like the bits I need. Body. Okay. That's not what works for me, is it? So again, I need some sort of body, and that's what I'm going to pass into the rigid body abstraction. Quicko is hoarding them all. I'm going to have one thing at one point, which is absolutely useless, but it's like, needs 200,000 points. Okay, and then we get the body interface, right? So that comes from the physics system itself. So physics, create body. So this becomes, so then we do something like physics system dot get body interface dot add body. Okay. And then you have to do this weird like body get ID and then some activation mode, which I cannot remember what that does. Ah, yes, that's something like GPH E activation activate, which I think we'll need to conditionally change based on whether it's static or not. But for now, that's kind of what we're doing. Cool. I can't. Piss off. Right. Yeah, I mean, like, no, but all great ideas, I'm sure. Okay, so why is that ID? There you go. Okay, so this is kind of what we need to get this body settings, which comes from the shape which we yet to construct. Okay. We construct this body. We then, which I think actually we actually do instead auto body equals hang on. hang on. Auto interface equals physics system dot get body interface. Pretty sure that returns a reference. It does. Okay, and then we can do body equals interface dot interface dot create body, create and add body all as one go. Man, was absolutely fucking around last time. And then I can do settings and then GPH E activation activate, right, something like that. And then we need to stick that into the rigid body, which I've not yet created, and then send it on its merry way. I'll have you know, I'm a very avid and keen home cook, so that would be that might be fun. It would totally a bit of a different vibe. Body settings, perhaps. Right. Okay, so and then I guess const auto. I feel like we need to have a auto to native to activation, and then this will have a physics layer, and then that becomes a GPH E activation. Don't know why it's and then we do switch on the layer, and then oh god, I hate that. Right, using enum the physics layer, we can do case static return JPH E activation activate. Yes, I know it's the wrong way around. Don't activate, and then this we can just throw FPS exception unknown layer type, and that should, I'll have to import the formatter, but that should use reflection to give us the name of the type if it's not supported, which is very nice. Right, jolt, do it. Right, all these jolts need to be moved over to the core jolt one, but one thing at a time. Hold on. I don't know who I'm talking to there. Right. Sorry. Over. Well, I don't know what my signature dish is. Sunday roast is actually what it is. Jolt. This shit in here. My now new least favorite file. This. Oh man, I can't spell. I'm basically illiterate. Okay, so now we should be able to do to activation layer. Okay, we're nearly there. 926 typo. 926 is this, mate. But I see what you mean. No, that was it. That was your one chance. It's gone now. I'll be rescinding all your points. Rigid body. Okay, so this is now going to want to have a actually include physics jolt, rigid body, JPH body, and then a GPH body non-owning pointer as far as I can tell. Didn't we have some? There was a bug in the last one, wasn't there, where there was a. It was the order that things were getting closed down in Jolt meant that we ended up with a dangling pointer. I wonder if we'll get the same again this time. So that's basically what we want. And then how do I stick something in the sparse set? Do I just use the? I just place it, don't I, with perfect forwarding. So I just do return rigid bodies dot emplace body. Why is it not like that? Variable with. Does that not? Gosh, gives you the body ID. What bullshit's this? Why would you? Unless I just use the ID and then I'm just passing a handle to a handle, but I feel like. Yeah, I can't. Auto body ID. Is that why I had to do add body? I wonder if that's why I had to do add body, because that gives you the pointer back, doesn't it? Create body, sorry. That does give you the pointer back. Yes, I do. Can you not get? Can I then return interface.get? There's no like get rigid body, is there? I hate everything. Okay, fine. Create body settings. I said what I said and I won't repeat it. Interface dot add body body get ID to activation layer. Right, okay. And then we can do return body. Right. We're nearly there. How do I get the position of... Do I track... the position separately? Oh, interesting. You also do need... Oh, maybe I do just need the ID. Because if you look here, everything I use is just the ID, but I also have to store the body interface. So I think I might have been right with that. There's no need for me to have that pointer. What I do need to pass in though is this interface here. I assume I can just forward this reference along, as in like pass it in. I don't think that reference, I mean, it's going to go bang pretty quickly if it does. I don't think I need to convert it to a pointer. So what a voyage of discovery this is for all of us. Right, okay, fine. So rigid body now also needs a JPH body interface. Do I want a reference? Do I care? I don't think I care because like this is going to have to be non-copyable anyway, right? Doesn't make sense to just copy because I'll get back an optional ref to it, so I could effectively then copy that, dereference the optional, get a copy of it out. But what does it mean to copy a rigid body? Like the physics system isn't going to know about it, so I think you definitely want rigid body equals default equals delete, and then auto rigid body const rigid body. Oh, hang on, what am I doing? Operator equals, there we go. What am I doing? Auto operator equals rigid body at equals delete. That's painful. Sorry about that. The interface is going to outlast any rigid body, so I don't point it. Like, but I would always prefer a reference over a pointer anyway because it's guaranteed to not be null, right? Obviously, it does have different semantics around equality, but I won't be comparing rigid bodies. And if I am, I'm going to have a custom. I'll have a custom operator which checks the body ID, but then that doesn't make any sense either because rigid bodies should be unique, so equality is kind of meaningless anyway. It does mean that these are then. It does now mean that's not move assignable. It's only move constructible. So maybe I do want a pointer. I'm just trying to think if I care about the semantics. It's going to be stored in a vector and sparse set, which I think handles this anyway. I'm going to leave it as a reference, but I might have to change it to pointer if the compiler complains too hard at me. I'm just trying to think. It's a multi-step process to go through here. I think it might need to be a pointer because I don't think I can store this in a vector now because it won't have a move assignment operator because you can't move you can't reseat the reference, so it's meaningless to. You can't move assign over something. So I think I'm going to err on the side of caution and do that. I could be talking absolute bullshit though. Also, I'm not bothering this time with the passkey idiom because there's no way you could ever construct this without being from within inside the physics system anyway, so you kind of get that for free. So body interface. Do I keep making the font smaller, or have I just been... Also, do we need... Well, the thing is, like, how would you... So the point is, why do we need to store the body interface, or can we just query it for the physics system each time? I don't like that because then I don't think that's great object design. Like if I have this object, right, called rigid body, I should be able to ask rigid body things of it. Tell me where you are. Tell me your velocity. Set your velocity, etc., etc., etc. If I have to go via the physics system, I'd have to do like physics system dot get rigid body velocity and then pass this in, and it's like but I've already kind of got that via the handle system, so it's like another layer of indirection. So I would prefer that classes are kind of self-contained with the functionality that you can query them. That's my personal opinion. I understand what you mean, I just don't think I need it in this sense. Also, it'd be very unlike any of the other code I've written elsewhere, so I'm trying to be consistent. So pass those in. That's going to want to be a pointer, and then we can store these, which means now we can just default these. Get rid of that, didn't want that bit. Yeah, that's fine. It's good to discuss these things. Otherwise, I'm just kind of making up. Well, I'm making up as I go along anyway. But it's good to discuss them. Right. I think this. So I think we want. I want some querying information from this. So let's do hash include. You can get Jolt to use your own transforms. Interesting. I did not know that. If you have a reference to that somewhere, that'd be really useful. I'm happy to include it. So far, I was just going to mash it through my own transformations, and then do my own conversions between the types. Math vector, and let's do auto position. It's gonna be const. Yes, sorry, 25 minutes there. Vector 3. Okay, so that's. I think that should be enough to get it going, because although we won't be able to see it to start with, if we just if we add it to the simulation and log the position, we should see the Y getting smaller, and then we can add a debug renderer. Yeah, great. Okay, so I think we're nearly. So I guess the thing I'm missing is how to construct this shape. And then that's going to be third address of, because who knows? Who knows what they've done? I think it's just address up there. Okay. Right, so the last thing now is I need to construct the shape. So let's go over to how I constructed the. I just know what Killer said about using custom transforms. I'm super curious about that. I don't have time to stop and Google it now, but if someone does know, that would be cool. So I want a auto box shape settings equals JPH box shape settings. Let's see what we got here. So half extent. I think that's all we get. We have to do it half extents. But I think we can. So that's going to be half extents. So that's going to be the origin plus. Wait a minute, is that right? Also, I was reading about this. You can assign materials to objects, which is really interesting. So it might be. I think this might be really useful when we do picking and like ray intersections. We can assign materials to things, and we shoot them. We can kind of know what material we've hit, and then do appropriate response to that. So I really want to revisit this later. This is going to be really interesting way of kind of combining the physics system with the entity system. But for now, how do you set? Is it just based at the origin then? Is this just assuming this is at the origin? Because in my abstraction, I just have dimensions. I don't have. So where do you set the position then? When you create a rigid. So I pass that into rigid body. Sorry, I'm just going through my old code. Oh shit, what have I done? Oh, that right. Okay, I got it now. So this is just in object space, local space, I guess, model space, and then the world space comes in the creation here. So this just becomes. If I have a min and a max, do I just average the two together? Do I do vector3? Sorry, JPH vec3. Yeah, okay. So it's gonna be AABB dot max dot x minus AABB dot min dot x over 2.0 f. X Z. So that should be enough to satisfy that. And then when we do the body creation settings, we do box shape settings, and then I need a. This is where I'm going to start building out more utils. So we're going to want to do auto to jolt FPS. This is what I'm hoping we. Sounds like we might be able to get around to doing this. But for now, your Z still has an Xmax. Yeah, okay, we'll fix that in a second. Good spot. Vec3. So this is gonna return vec.x, vec.y, vec.z. Max, min, max, z. Thank you very much. Okay, so now I should be able to do box shape settings, 2 jolt. I hate everything. I'm gonna try and keep these consistent. So we're gonna have, when we specify future objects, we will have shape specific stuff first, then position, then the layer, and then so this is going to be position, and then we're going to want GPH quat s identity, and then type. I think this just becomes. I think it's just the layer. Okay, right. What have I done wrong? So let's just fix up my interface first. Vector3 const vector3, which is now incorrect in implementation. What are you going to do? What are you going to do? We're going to fix it. That's what we're going to do. Const fp. In fact, that AAB needs to be const ref as well, doesn't it? It's not trivial copyable type. That was wrong of me to assume so. Sorry, quick refactor, super quick, in and out. All right. Is it minus or is it? I thought you took the. Because I need to get the half extents, don't I? So I work out the distance between the two of them, and then I halve it. I think that's right. We'll soon find out. Okay, so why is it not like this? No, need to add it to the min. Yes, because this will almost certainly be negative, so minusing it will actually add it to you. Is that right? Well, we're probably working out right. If we had the max at 1 and the min at 1, I'd expect the extents to be 1. So 1 minus 1 is 2, divided by 2 is 1. Okay, why is it not like this? So this takes body. Ooh, doesn't like. Am I missing that from the header? No, I have it. So body creation settings. It takes a shape settings pointer or a shape. Shape settings. Does that mean does it take ownership of that? There needs to be a jolt layer. Yes, I think we can just cast that because we've assumed everywhere else that those are the same. But that's a good point. Is it really that? Does it take ownership of that? Is that why I had to? Right, okay. I had to, when I did it last time, I created the shape settings with the dimensions and I had to do set embedded. Oh, okay, fine, never mind. But thank you. Let's just rewrite it in bullet. Okay, plenty of things. So that's set in. It's really not clear to me how this works. Can I get the jolt source up? Jolt source. And then what's the file? It was like body creation settings CPP. What does it actually do? So what was the? I just want the straight up constructor, don't I? Okay, the constructor doesn't exist there. Maybe it's just in the header file. But, oh, it's gonna go down this miserable. Okay, fine. Where's your implementation? Like, those are the constructors, sure, and then but in. Right, I hate all that. So let me open up in a tab where I can search because I'm not signed in on this. Shit, just close something I didn't mean to. Can I get that back? Yeah, yes I can. Right. Jolt source. Hold on one moment, caller. I love the fact that you have to be signed into GitHub to search. That's a really nice feature. I suppose I could open it up. I do have it checked out. Is it generating it? I couldn't see. It just makes it serializable though, so I don't know if that necessarily generates the constructor or if that's just generating serialized metadata. It's in the. Is it? Where? Was I just being stupid? Oh my goodness, I was being stupid. Thank you. Sorry. It's because whatever formatting system they have means it all goes on this one miserable line. Okay, so shape settings. Where does in shape go? Where does in shape? So M shape. Ugh, thanks GitHub. Could you not? So what's M shape? I have a horrible feeling this is. So is this taking ownership of this? See, when you do set shape, right? You pass in a new pointer, which does very much imply that it is owning it. Oh, but that's grim, because then this doesn't give you the old one back. So who frees that? I wonder if this is why you need to persist it somewhere and then set the embedded, because it has its own internal reference counting system. I've got a vague memory of this being something before. Oh, let's worry about the leaks some more, just the inevitable crash. Here we go. It has a ref const, which is a... Oh, we looked at all this last time. Ref. Simple class for set reference counting releasing. Reference counting integer. How many references do reference counting is derived from the ref target and stats and the life. Okay, so you have the T ref. What is this storing it as internally? That's the ref target. I want just the ref itself. Ref const, here we go. What's this? Yeah, right, pointer to an object that we reference can. So this does take ownership of that pointer. Which means I'm going to assume this has a well-defined assignment operator, because actually, in fact, then is it set shape settings? Yeah, this will call the assignment operator on that ref counted class, which presumably does decrement the old one for you. So that's fine. So this is going to take ownership. So I cannot pass a stack allocated variable into this. Does Joe have docs for this? I don't. I mean, it's got this, but this looks awfully like just a Doxygen generated page. I suppose it does have this down here. But does this go... This all talks about like bodies and constraints and stuff. Does it actually talk about the internal mechanisms for like its internal reference counting stuff? Is this... I suspect this is not developer documentation. This is user documentation. I could be wrong. It could be in here somewhere. Can I search for ref const and not just get the class? Otherwise, I just get this, right? Which is worse than the source code, because at least I had the implementation. Like debug rendering, sure, like this is useful because I want to read all this and go through all this and like the simulation step and all this stuff, but I don't think this gives us like developer level documentation. Well, I'm less after how it's done. I'm more after how it's like what it's going to do with the pointer that I give it. So can I... It's a raw pointer though, isn't it? So who's... If I knew it... Let's have a look. What's... Where do I have the ref code? Do I have reference.cpp? Oh, is it just header only? Okay, fine. So what was it? Ref const, add ref, release, endpointer release. What does release do? I want to see inline void release. Which class? Ref. This is ref target. I don't know if that is somehow related to reference or not. Here you go. Ref target virtual. Ref calls release. User calls... What was if my... This must wrap something. Class 1, this is kind of a pointer type T. If you assign a value to D... Okay, I'll have a look at that in a second. At the moment, I'm just going to see if I can figure out myself. because this is strange. So this is going to take type T, and this returns type T, but when it does release, use variable 9 points to release an object. Do not call these functions. Okay, this calls endpointer release, but that's of type T, right? So pointer to the object that we reference. That's strange, right? That does that not make any sense to anyone else? Am I just being stupid? Like, what if I pass in an int pointer? Unless you can only pass in jolt types. Do jolt types have a release method? Const pointer to if you assign a value to this class, it will implement the reference counter. Like, because we can see we have a ref const of shape settings, right? Where is shape settings defined? Sorry, I'm going on a bit of a jolly now, but this is kind of, I think this is kind of good for us to build out our understanding. Physics. Is there a shape settings file? Is there a shape file? Collision shape. I'm in the flow now. I'm in the flow. Box shape settings. Okay, so these are the convex. Okay, fine. So we're going to have to go up this hierarchy here. So let's go. I suppose actually you're right. This would be really easy at this point. So let's do. Can I do that? Okay, and then convex shape. Oh, great. Okay. PangD is having a fit. Public shape settings. Please work. Nope. Okay. Have I got a release in here? Nope. Where does this live? Shape, I guess. Release. Shape settings. It's a serial and it's a ref. Okay, fine. Okay, so shape settings is itself. Ref target is it allows you to reference count it. Basically, if you inherit from yourself. So is that what CRTP? Ref target is basically a mix-in, then that allows it to be reference counted. Okay, that's fine. So what does... So do I have a release? So what does ref target release do? So this is the ref target. Okay, fine. So this will eventually cool down to this. It calls delete on it. So that means, what that actually means for us is I think we can do new and pass that in, which will then go through the ref, the const ref as a pointer, but because this is itself a ref target, will expose the release method, which will then call delete on it. Yeah, maybe I'm wrong. Maybe there are better ways. Like this is, but I think that's what we want. And this is exception safe as long as these don't throw, because it will. I mean, it's not guaranteed, but they could evaluate right to left. It does look like it. I think we can basically say Jolt will take ownership of this. We think. I know, right? It's very rare. Very rare I get to write a raw new. It feels wrong. I think we're done. Well, I do have profiling for memory now, so we will see if there's a memory leak. Of course, what I really want is an address sanitizer, but maybe one day. Okay. think we've got to implement all this governance now, right? VS. Let's do E source. Not that. E source physics regex body, and then let's do hash include physics regex body. That's not what I wanted. Name space. Oops. I think I looked at the. I seem to remember looking at the example, the Hello World last year, and being like, raw new, that's wrong. There must be a better way of doing it, and then coming up with a really convoluted way, which meant I didn't have to write raw new, but I think that's demonstrably wrong now that I kind of reflect on it. If you set bounded bar on a stack, it will ignore ref counting, and then you just allow it to deconstruct after creating it when leaving the scope. Oh, okay, so does that mean it then doesn't take ownership of it? So why does it... just functionally then, how can that class operate with either, I guess, having or not having those shape settings persisted? It just seems strange design to me. Again, this is just... However I use Jolt is influenced by how I tried to figure it out doing this live a year ago. So there's definitely some probably non-idiomatic usages. Trying to iron those out as we go along, but also at some point we kind of just need to make some progress, which is probably the attitude I took last time. So again, I'm in no way claiming to be an expert in Jolt. I'm just trying to, feel my way through it. Get my divining rods out. Divining rods? Divining rods out. Okay, so let's do rigid body. You want some of this. And some of this. And none of that. And none of this. Rigid body, bang, bang, and then dot there. Oh, nope, steady. Body ID, body interface, bish bash bosh. I've got some code for this somewhere. How did I do this before? I've gone too far. So we're going to do... Gonna need to pull this out to some... Do I stick in the Jolt utils? I suppose it... really do hate this file. But I could do... no, let's keep it. Oh, I'll have to include it anyway. Not sure how I feel about this. Inline to native. Const h vec3. Don't they have like a vec3 arg, which I think that's already const ref. Okay, it's just const vec3. Why are these refs? Why does that get to be a ref, but vec3 doesn't? They just assume they just are happy to pass it by value. Vec, and then that becomes hang on. Vector3. Return vec dot. Oh, get x. Wow. Vector get y. Vector get z. Are you guaranteed to get it into the SIMD registers though? Either way, consistent with everything else I've used. Even for, is that guaranteed though? I'd have to check the standard. I can't remember whether that's guaranteed for aggregate types, if it will load them in. I'm not saying you're wrong. I think you're probably right. It's just not intuitive to me. How am I finding the API? It's okay. Like, I think there's a lot of design decisions that I personally wouldn't make. But like, I think when we get over this sort of setup bit, it's really not that bad. Yeah. Anyway, doesn't really matter. Because it has to be, the address has to be 16-byte aligned to go into an XMM register, right? So I don't know if you can guarantee that unless it has an alignment type set on the vector3. I don't know if I can see that. Okay, fine, clever. It does have JPH vector alignment, and it stores them as 4 vectors. Interesting. So yeah, I reckon that's JPH vector alignment is probably 16. Smart. I should probably do something like that for mine. But well, doesn't matter. And then didn't we have another one of these? I put in an anonymous namespace. I think it was in the physics system. We might as well start hoisting these out. D37. Actually, take that back. I think the activation layer is so specific that should stay here, but this one can come out. Yeah, this is a bit I'm not sure of. I'd have to go and have a look. But anyway, it doesn't really matter for what I'm doing now. So let's go back to rigid body. So this can now be body interface get position of the body ID. Right, that's all you have to do. So you're effectively calling back into the physics system, right? We've just embedded that type in it, and then I'm going to need to do return to native, something like that. Any GPU acceleration, I'm kind of letting Jolt handle itself. I'm not really kind of stepping in on that. We have a GPU renderer though. Yeah, I mean, let's just see if this works for now. I mean, but we can tighten it up later. Okay. Has it been any there? So I guess C make physics. This is going to MNOPQ rigid body dot CP. See if this blends. Almost certainly will not. No matching call to body create settings, body creation settings. Okay, what can you not convert? It doesn't like this in motion type, I think. Is that in physics system? Ah, I see. I'm missing an arg, am I? I just chose to ignore me. Is it? Do I need to put that in both? Okay, what have I? Why is this? I don't know why Clang D is having a fit, and sometimes we'll find it and sometimes won't. What do we? Was it that anyway? Body creation settings. So it's got here. The constructors are an in. No, I want the in shape settings one. You gonna show it to me? I can't see it. Shape settings, position, motion type, and object. Ah, here we go. Is it two activation layer like that? What's the emotion type? Can I really wish I could get to this. Here, emotion type. Oh, of course I can't find it. Motion type. Static, kinetic, dynamic. Okay. Why do I need to specify that? I guess you could mix those things within the different layers. Okay, fine. It's fine. To motion. Emotion? Is it type? Emotion type. Static. Emotion type. Dynamic. Okay. Okay, fine. So then we go to this, and then this becomes to motion. Might still not like that last argument. No match function quarters. So we've got the shape pointer. I think that's just the layer, isn't it? Shape settings, in position. It just needs the object layer, which I guess I probably need to cast. I think that's just a cast. I think I'm just a cast away. Not cast away, but you know what I mean. I may need to do to underlying there. Indeed. I need to upgrade the linker as well. I think I'm using an old. I think I'm just using, is it LD? I think mold or something like that, or gold or something multi-threaded. Might be a bit fast there. Okay, let's do this. Let's go to main. I've been in main for a while. Let's go to main, and let's do hash include graphics. No, it's fine. I don't need to do it. No, not physics rigid body. Okay, and now let's try. You know what we could do? We could do it as a coroutine. I'm just saying. Why have I not got it's a rigid body handle, isn't it? Rigid body handle. And then we can do no, we've already got coroutines. It's fine. It's fine. It's fine. It's fine. So we can do if. Let's show you how it kind of works under the hood, actually. So if we do pass in the UFPS physics system physics, what we can do is we say if physics dot if const auto physics dot RB equals physics dot rigid body handle. I don't originally like RB, let's call it body. Body. Alright. If we have the body, else co-return. And then we can do UFPS log debug body calls body dot position. I guess we could just do like await. What do I do? Await all. So actually, we'll just spin that. Busy. As a C++ programmer, what key and keyword has been pressed the most? Colon or semicolon, I would suspect. Maybe dot? This is just an infinite loop, and it's just like one character shorter. It's shorter than while true, and the same as while one. But I just think it's kind of fun. Oh, no, the same key. Yes, what a great, what a great observation. I wasn't even thinking about that. Okay, fine. So let's do. Where do we create the physics system? Physics. Let's do auto. Do you not have a yield return so you don't lock the thread to it? No, because when it goes to the awaitable manager, it'll automatically schedule it for the next tick anyway. So the kind of backend infrastructure should handle that. Body equals physics dot create rigid body. I'm going to create this maximum 1.0 f, minimum minus 1.0 f, so it's going to be 2 in size. And then the position is going to be 0.0 f. Let's do 5.0 f, and then minus 5.0 f, so it should be in front of us, I think. And then UFPS physics layer dynamic. And then we can do we separate. We can do logbox, await manager, body, physics. Just trying to miss anything. Unless the await manager somehow yields, it shouldn't do it. It should all. I think it should all just work. Because it will just push that to a thread to execute until it co-awaits again, until it goes back round. Oh no, you're right. You're so right. I do need to co-await something, otherwise it will just sit in an infinite loop. Yes, you're right. Sorry, I do need to. It does. It needs to be able to reschedule itself. So it needs like a pause point, doesn't it? So let's do that. Otherwise, that thread will just lock. Yes, I see what you mean now. Sorry, I missed that. It's not looking good. I think it's crashed. Invalid. Half extent. That's from the jolt trace as well. Let's do physics system. Jolt trace. I don't think I can get out of this annoyingly. What actually no, what I can do is I can do error. So let's do log. Let's do if const auto error view str equals stood string view buffer.data write count. Yeah, okay, then we can do if error str dot starts with error. Then we can do throw UFPS exception error str. Else we will just log it as info here. Okay, fine. I just want to just see if this works and this machinery works. Because we should respond to jolt errors like that. I mean, it's a bit annoying if the only way we can find a jolt error is if it's through its logging mechanism, but okay. Boom, stack trace. Thank you. Physics system, body creation shape, GPH body manager, physics system crate box at physics system 119. So it doesn't like the body settings. So what was the actual error message? It was something like the extent was wrong. Invalid half extent. Use the box set and create the shape result. Okay, fine. We might refactor that. So, what were you saying? We think we can use auto box equals GPH. There is an AA is it box shape? Or do we use auto box equals box shape settings dot create, and then we do box dot box doesn't have a set embedded then, does it? Because you're saying then do this, right? What does this return? A shape result. Got you. Okay, fine. So that is a result type. Of course, it's not going to show me what that is. It's basically still expected, I guess, isn't it? Box result if box result dot has error. Actually, no, sorry. Ensure not box result dot has error. Box error. Box result dot get error. And then so that will check that, and then we should be able to do, I guess, what cont auto box equals box result dot get, and then that's probably not constant box dot set embedded, and then we pass this. Is that a pointer? No. Okay, so we do the address of something like that. Create const. It does take a shape. I suppose I could just go look at the Hello World one, but I feel like I'm very close to figuring this out for myself. I'm not sure why it doesn't like that. The get will probably return, is it a reference? Yeah, const reference. Okay, so do I need it to be a const pointer? No, sorry, const there, and then that should give me get returns a ref. So you just set better. Well, no, surely that's going to get it from the box, the thing I've created, right? Because I've called create. Where's the jolt? Jolt. Hello world example. Because this is pissing me off now. This isn't even the problem I was trying to solve. Set embedded. So box shape, floor shape settings, reference objects on stack. Okay, so you do want to do it on this. Okay, fine. So you do box shape settings dot set embedded, right? And then we do floor shape result dot get. And what does it do with that? Body. So then body shaping start. It just passes the get straight in. I bet that needs to be a reference. That's why. And then body creation settings. That seems to think you can just pass that straight in. Am I being stupid somewhere? Okay, fine. I must have missed that. Get rid of that. Okay, I think we're there for that issue. So now, I guess let's do UFPS log debug AABB. AABB. So that's that. I suppose I actually probably should have checked what the half extents was, shouldn't I? Const auto half extents equals. Ooh, steady. Vector 3. And that should be 2 jolt. Half extent. And this should be and I'll do half extent. Half extents. You got your min and max flipped, have I? But I want to do the biggest number minus the smallest number, right? Oh, in main. Oh, that's funny. Yeah, you're right. That is funny. No, I just don't know what I'm doing. It's crashed. So that's right. But then it's just straight up just died. Nice. Yeah, but the half extent should still be 1, right? So it's crashing physics system 1.5. There? Is it on my thing, really? Or is it crashed on the line before and it's just GDB? I'm in a funny 5 minutes. Get error. I know exactly why this is. It's because we've had this issue before. I bet it's evaluating this before it's evaluating this. And I bet this is undefined behavior if this is false, if this is not true. Oh, that is grim. Right. Ugh. Fine. Have I got it the wrong way around? Yes, I have, haven't I? Yes, thank you. because you ensure the opposite. But now I'm checking. Well, you ensure one thing, but now I'm checking for the opposite. Nope, no macros, no capes. Okay, that looks good. Let's check the logs. I mean, it do be falling. Presumably roughly 9.8 meters. Well, it won't be accelerating anymore. It would have hit terminal velocity. Ship it. I've probably got some logging in here. I don't need anyone. Get rid of that shite. Okay, let's comment this up because it's quite a big change, and then we'll start for like a little bit of time working on the debug renderer so we can see it. More jolt includes all the jolt includes all the time. Add rigid body class. Create rigid body. Integrate changes. No. Okay. So that's done. I'm going to have to look at how I did the debug render in the last project, because if anything, if I remember correctly, it was grim. I think it basically just screams a long line of lines at you, and you basically just have to deal with it. So the debug renderer, already hate it. We construct a debug renderer simple, and then that gives us draw line, draw triangle, draw text 3D, and then we accumulate those lines as line data in vector. We can clear it, and then we can get a span of those out, which I think basically means we then copy that into our current renderer. And then what's the implementation like? Draw line, we just push 2 lines back. Draw triangle, we just draw lines for those. And draw text, we basically like, sure. It's not too bad. So we have, don't we? We have our current debug. We have a whole debug renderer now, which already handles a bunch of which already has draw line gubbins, right? It looks very much like this. So where do we? This has a debug lines. That's it. So I think what we want to do is in our post render step, which only the debug renderer implements, because this is where we draw the debug lines for the bounding boxes, right? So when you're, let me show you. There on it. So when we select something, we get debug lines around it, including the lights as well. I think, has that got a green? Got like a? No, I thought it had a. It might actually have a red box around it, which doesn't particularly help. Yeah, it's got a red box around it. So when you're selecting lights, sorry, when the lights are rendered, they have a red outline around them. And then when you select anything, so we already have the ability to draw colored lines. And we do this better than because if I remember correctly, in the last time we drew the debug lines before the post-processing, so they would have like weird SSAO artifacts around them, but now they're all drawn entirely, because it's a post-render step after the final scene has been composited. we then grab the depth buffer and draw the lines into it. So we just basically need something here which is just like draw debug lines. Sorry, draw physics lines. I think we're reaching a important fork in the road here. Important junction on our journey. Yeah, you might be right. We might need to add it to these. No, this is fine because these get drawn later. Right at the bottom here. See, literally here, this is where it binds the debug line program and draws them all. Debug lines append range. Here you go. Debug lines program and bind. This is where it handles all this govern. So as long as we have the lines in the vector, then they will get rendered. So it builds the debug renderer data stream simulator. Yes, basically. I don't. Well, this is. I think maybe this is the point I'm trying to get to. Is like we're starting to get some coupling now. Like I will have to construct a jolt debug renderer, right? I could make this another subclass of it, but that seems a bit gross. It also means then I have to construct the physics system, I guess, before the renderer. But the thing is, like, there's a bunch of stuff we're just going to need to throw around, right? Like the physics. Now that we have the physics system, like things are going to need to have access to that. For instance, same as like the texture manager that we've got and the material manager. Yeah, but what I'm trying to do is I'm trying to bring some chaos, some order to the chaos of coupling. I don't want it to go rampant. Like coupling is inevitable, but I want to kind of control it. So at the moment, like where's main? Like we set up like an awaitable manager, a thread pool, a mesh manager, a physics system, like all these things, right? And at the moment we basically just stuff a load of them. We stuff like these two into scene and just pass it around. We could just use pure dependency injection, right? So you just pass everything that needs it takes as a constructor and get on with it, which is kind of, I guess, the sort of traditional way of doing it. The problem with that is everything has pros and cons, right? The problem with that, or at least I have, is that you're going to end up with a lot of like tramp data. Do you know what I mean? Like you're going to have to muddy all the interfaces because some component like quite embedded in some subsystem somewhere is going to need the physics system, which means you're going to have to pass that into its constructor, which means the thing that builds that is going to have to take its constructor and blah, 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 blah. Which means now everything, it's kind of a weird interface, right? Because now everything it's just taking this physics system just to pass it down. And like you could argue that for the debug renderer, like the debug renderer will now need to know about the physics system, right? Even though it's just purely a renderer. The other alternative is global variables, right? Which I'm also opposed to because they hide complexity and state, and it's kind of very hard to worry about what's going on. I think for this case, I would rather a few globals than having a really complex runtime dependency injection framework, but via a little bit of abstraction. So what I'm thinking, because I've been thinking about this a lot, what I think we might want is like the effect of the service locator pattern, if anyone's familiar with that. We bundle all of our globals into one place, and then we provide a single function which basically says, please, from the bunch of services that are registered to be accessed via the locator, get me the physics system, and then it will return you a reference to it. It does mean that we'll basically have a load of like service locators embedded around the code, but I think that's inevitable anyway. And then it does mean we can kind of control that a little bit better. So I'm tempted to give it a try, just to see how we get on with it. This seems like a good chance, a good excuse to use it. And I feel just having some sort of like global god thing which just has the managers in it. It's probably, I suspect, probably not a million miles off how a lot of engines do it, having never really looked at another engine before, but it seems like a sensible, reasonably sensible choice. Yeah, like a manager of managers, if you will, like the area manager. Let me just write some code, and then we can see what we think. Right. So I'm thinking of something like source core service locator, right? Hash include tuple. So what I'm thinking of is something like that might not work because then it's going to need to know the size of it, isn't it? We could make it a unique pointer, but I wonder if that's making things more complicated. Let's just try it. Let me just try that. I've not done this before, so I'm kind of feeling out the API as I go along. Do I want that, or do I just include it? Problem is, then I could end up with circular dependencies if any of the header files need to locate a service. So say we had something like that, and then we can have a unique pointer for all the types that we want, right? And then we can have an import which actually has like services G services equals G services. Right. Lavender Dev resubbing for 1. Thank you very much. And then we have something like template class T auto service T equals return std get T of import G services. Something like that, right? Oh, sorry, it should be inline. Is there a reason it couldn't be a global struct? I guess. I just assumed tuple would tuple be easier. No, it is. It has to be a tuple because I want to do this. Unless you're suggesting we use reflection. In main once. Because what I want, the interface, right, is I want to be able to do service, physics manager, dot create box, whatever, right? G services. Oh, I see what you mean. Just do that. Is there a reason why I wouldn't want that? yeah, I guess a struct could work. Could it work? I guess. Why do I not want to? I think because I want to abstract this away somehow. Like, I know it being an impl namespace is not that great, but I don't want people to be accessing G services. I definitely want to go via a function. I want people to say service this and get it to me. That is the API that I would prefer rather than just some random global. It feels better in my mind, for one. And for two, I want to be able to force the construction of this pretty much in one place. Yeah, I don't think it matters it's in a sub. Does it matter it's in a sub? It will need to be in a sub namespace, I think, because this has to be declared before it anyway. It doesn't really matter. Because I also then want a auto set service. And then this would be like, effectively it'd be cert impl G services doesn't equal null pointer. Sorry, cert it does equal. And then do G services equals services. But I can't have a singleton because I need to be able to control the because you have to remember. I mean, think about this quite a lot. A lot of these will still have some dependencies on each other. It's totally possible that they might have some. We still want to be able to control the construction, and I don't want static initialization, because then you get into the static initialization fiasco and the deallocation fiasco. I basically want in main. Right, once the program is started, I want to be able to construct all of my sub-objects exactly how I want them, stuff them once and only once into this, and then just use it for the rest of the application. So the problem with the Mayor singleton is I don't think it gives me that flexibility. Like, it will just construct it, but how do I pass in arguments to it? What if physics system needs an argument, right? So this is a very specific issue I'm trying to solve, is that I want to be able to construct a bunch of things that may be interconnected in some weird way, right? And then once and kind of only once, I get global access to them. But I really want to restrict that to kind of a very simple API, right? I'm trying to think if there's a way I can. I don't think there's a way I can hide this, but I think this is kind of good enough. You know, like, should we go to main and see where we end up? How can you hide it in a source file though? Because I still need to return it. I still need a pointer to it available in the header file, right? Core. That's okay. Let me just write out what I want to do, and we'll see if it makes sense. So let's do physics system. So I want to be able to do a std make unique FPS. Ooh. And then do. Oh, that's nice for that. And then do. So that's fine. We can still use that there. And then. So. Auto services equals UFPS services. Services dot. No. Here's what I want to do. I want to do std make unique services, right? And then that would be stood move physics, which means this is no longer going to work, but we can check this works in a second. No, I'm beating this out as I go along, and then we can do UFPS set services dot get. Thank you very much. Very kind words. Okay, fine. So because BioCoas, by doing this, right, by effectively heap allocating the whole services thing, but keeping this on the main, this guarantees, right? So this is one of the other problems I want to solve, is that when start finishes, effectively when main finishes, this will get deallocated, which means I can effectively close the lifetime of those services exactly when the game ends. So if anything weird is happening afterwards, like holding on to, like, I want to make sure that all those services are tightly scoped to main. I don't want the option for those to be kind of used afterwards in weird ways. So I own the unique pointer to it in main, which will get deallocated at the end of the main, but I stick a pointer to that anyone else can access, right? So anything that accesses after main's gone, I would say is axiomatically incorrect. That is against the design of the system. The only issue with I think I see what you're saying is you want to say stick this in an import file and then just basically declare this and move this over to the implementation, but that won't work with the templated class, right? This, I don't see how this could work unless I list out all of them individually, which I don't want to do. So I think we can get away without declaring that there, right? No, you can't spread templates between headers, and you can't declare them in the header and define them in the CPP file, because the compiler needs to know everything about the point at the point where it instantiates the template. I don't. How is unless you want to extern it? Yeah, exactly. I don't think it's possible. I mean, I could be wrong, and I will have a think about this. But anyway, this is what I'm thinking. Right? I could be wrong. It could be absolutely the worst thing in the world. How does it know how many services you're passing? Because it's defined here, right? I still have to hard code this, but I only have to hard code one thing. So let's try. So now we should be able to do services UFPS physics system dot create box, right? Sorry, service. Yeah, exactly. So extend doesn't help either. Does allow you to instantiate new physics objects during the main game loop? Yeah, it should do, right? Because this is exactly what we're doing here. We're initializing this here, right? So let's just see if this works within main, right? Because we've got a couple of places where we've used it. So this means now I technically no longer have to do that, right? Oh, hang on, no, what am I doing? Alright, so that should work. So then I should be able to now, here, get rid of this. And just do auto physics equals UFPS service UFPS physics system. Alright. And then in the up, where do I update the physics? Just something like that. I don't know if I like this, but I just wanted to kind of, because I didn't probably have enough time to write all the debug render stuff anyway. It's kind of interesting to take this point to think about this. So does that run? Does that work? Okay. Yeah, it's fucked, I think is the technical term. Actually, I think I know what it is. Can't pass a pointer into std get. We'll need a reference. There we go. Oh, so close. So close. Why is it not? Which operator style you? Operator. Oh, hang on. There you go. Ooh, Sabbase service is already set. That seems highly unlikely. That will, if we like this design, or if I like this design, that I think might be our first contract. But I won't be doing that tonight. Why is it? Oh, ugh. Yep, thank you. Obviously. We could have a reset one as well, which checks that it's set and then sets it to null. And then we could have an RAI wrapper, which automatically does that at the end of my... Oh, no, I'm getting ahead of myself. Did I forget the bang? So this should fail. Nice. Get there in the end. Sorry, chaps and chapettes. I'm going to sleep on this design because I don't think it's the worst thing that we've written. But I think it could be interesting. Right, okay. Right, so we're still falling. Right, so this is now doing everything we did before, but going via the service locator. Which I don't think in the context of what we're going to doing is bad. I think we're going to inevitably have to have all this global stuff anyway. Yeah, so so now basically the physics system we can construct the physics system with an optional debug renderer, right? Okay, which we can turn off in release builds, and then the debug renderer can query that, get it if it's there, and then use that to extract the triangle information out. So it keeps those kind of separate, and then there's this like thin little kind of like wormhole you have to go through to get the stuff. So let's add locator. I can get rid of that. Use service locator. Right. Stick those in the git hole, and where are we at? Stream 40. Could you quickly add physics objects to the objects? No, because I think that's a rabbit hole that I'm going to fall down, and then I'll end up not getting any sleep. So I think we'll just save that for the next stream, but it's a good idea. Where's me? Oh yeah. Right. Okay. They've got quite a lot done today. Like we finished doing we can now create rigid bodies and simulate them, which I think is a pretty big deal. And then we started on the service locator abstraction, which I think I'm going to stick with. I think I'm tempted to give it a go, at least for the physics system, and bring some of the other stuff and just see what it's like. I may off stream, if I get time, refactor some of the other managers we've got into that, and then just clean up all the interfaces, just so we've got something a bit more meaty to play with going forward. But it'll just be that. Like I won't be doing anything interesting with it. Do I accept pull requests? No, because this is basically like, it's a little bit selfish, but this is like me doing something live, and there's no real component of that at the moment, which means I'm kind of accepting contributions. That's just the way I've decided to do it. And maybe in the future I will, but not at the moment. You're of course free to fork the code and make any modifications you want. And do come along to Discord and let me know what you're doing. And if there's interesting stuff, maybe I can kind of incorporate it. But this is very much a me writing code and explaining my thought process, not me reviewing the code kind of live stream. So that's just the way I've decided to do it for now. I think that's kind of it. I don't think I've got any free. Have I got any free gifts? Have I free gifted? Hold on one moment, caller. Pay with my own money? No, you're right, mate. Oh, I hate everything. There's literally no one streaming with the CPP tag, which is absolutely wild. Oh no. No, there are a few. Hang on. One person is doing C++ no engine 3D dev, day 118, progress 12.6%. You should definitely go and say. And his tags are safe place and C++. Let's go do that. He's streaming to one person, so go show him some love. Go ask him some C++ questions. I'm going to wait a second and see what happens there. Other than that, thank you very much for coming and keeping me company. As always, I greatly appreciate it. I would just be doing this by myself and getting grumpy solo, so it's kind of good to vent my frustrations. Next stream, which I guess will be Wednesday, we're going to keep going. We're going to do the debug renderer. We're going to see that box fall, and then we're going to start adding some static stuff, and then we're going to start adding some level geometry, and before you know it, we're running around that little spaceship, bumping into walls. Other than that, thank you all, and I will see you all anon.